Hello, welcome back to the continuing lecture in investments. So, in our last video, we actually calculated, we did an example of, finding um, predicting, predicting the bond price change. I mean the amount. The amount change in the bond price when we have the interest rate change, right? Forecast of interest change and the duration. And we did that, with a 30-year bond. Now, there is another way to calculate duration, and which is, using, this is exactly the same. This is exactly the same example as spreadsheet 11.1, 8% coupon bond, where yield is 10% or interest rate is 10%, and 3 years, right? And using the okay, these calculations, let me. This is an already pre-built formula in Excel. Excel's so this is not very interesting because it's not really anything mathematical, but just so the initial data, it was a 3-year bond, right? 3-year, right? 3-year to maturity. So our you don't have to enter it like this. I mean, all you enter like January 1st, 2000. It goes in exactly. Oh, that's 20. So let's make it more interesting. I mean, if you enter it like that, it automatically comes out like this. So you don't have to follow this. Now, let me enter, because it's 3 years. Let's enter more recent without using that. I'll just enter 1/1/20. Okay, and then this will be, if it is 3 years, 23. Right? Do this. If you if you want to, you'll simply need to change this to 2020 and 2023. Right? And you can enter these as percentage, right? There you go, percentage. Use 2 decimal places by default, right? Coupon frequency once a year. Now, Macaulay duration is, simply, called duration. You just enter just PU and it already gives you duration. Double click, right? And then enter settlement date. Settlement is always, now, right? Maturity date, okay. And then the coupon rate. This is the coupon rate. And then yield, right? And you enter frequency, right? Hit enter. You get, right? And modify duration, right? And you can use, M duration, right? So M and you get modified duration, and you just do the same. Enter settlement date. Yield, time in maturity, and the coupon rate, and then yield, frequency, just one, frequency, right? Or I will put one, right? Hit enter, right? Modified duration, and what is modified duration? Well, we can easily, it's duration, Macaulay duration divided by 1 plus y. So all you need to do is then I will try that divided by 1 plus. Right? There you go. I got the same number, right? Okay, got the same number. And what about, let's match it with example 11. Let's try that one. In 11, example 11.1, yield is 9%, right? And 30 years, right? 30 years. And then coupon rate is 8%. So, and then it should come to 11.37, right? So let's do that. I'm gonna copy the whole thing. And then paste it here. All I need to do is simply change the, make this, 30 years, Then 2020, 30 years later, 2050, right? This is 9%. Just change that and what do you get? 11.3738. I got exactly the same number, right? And then a modified duration, something. So it's relatively easy, right? Okay. And I will put, this is, I'll put here, I'm gonna what am I going to insert? Text box. I want to insert it here. I will call it example 11.1 and give it nice font, make it bigger and something that looks okay. So this is example. I will also give it some nice font color. So we will. Oh no! What did I do? I was okay. Okay, this way we get the same result, right? We got the same. All right. So was spreadsheet 11.2, and then we move on to the next section, which is, let me switch, right? I'm gonna have to stop sharing this and start sharing the PowerPoint, right? By now you should be able to see, where is it? Oh, there it is. Okay. All righty. So our next question is, what are the determinants of duration? What determines the duration? Again, just like Malkiel's, rule, there are Malkiel's, theorem. There are 5 rules here. I mean, for Malkiel's theorem, there are 6, including non-Malkiel. But as for the determinants of the duration, there are 5 rules. Rule 1: 0 coupon bonds duration is the same as its maturity. Yeah, we've seen that. No questions, no further questions. Rule number 2: holding maturity and yield constant, duration and interest sensitivity of price, right, is higher when sensitivity is higher when coupon rate is lower. And this is pretty much, the same thing as Malkiel's theorem number 5. And it is, quite obvious, because low coupon bonds have even if maturity, let's say maturity and discount rates, interest rates, being held constant, obviously smaller coupon bonds have less contribution to the present value of the bond, right? And then when interest rate changes, it would fluctuate. This makes bond price fluctuate more. The present value of the bond fluctuate more than higher coupon, because the lower the coupon rate, the less weight early payments have on the weighted average of time periods. In other words, what does this mean? This is weighted average of time. This is another way of saying D, right? Now, so the lower fraction of that means lower fraction of the bond price is tied up in early coupon payments, whose values are relatively insensitive to, insensitive to interest rate rather than face value and later coupons, right? Why? Because earlier coupon payments are not discounted deeply. Earlier coupon payments are, it's discounted at best once, twice, 3 times, right? And those, because coupon payment is small, they definitely have less impact on the price. Now, rule number 3: holding coupon rate constant, duration and interest rate sensitivity of price generally increases with time. Of course, with maturity. Of course, the longer the maturity, right, the longer the duration, price sensitivity also increases. I mean, even before this topic, right, even in Finance 100, I told you the reason interest rate risk is called price risk as well as maturity risk is because the longer the maturity, the greater the chances of interest rate fluctuation, and the greater the chances of price dropping, right? So that's basically that. Duration always increases with maturity. Yes, of course. Duration always increases with maturity for bond selling at or above face value, right? Especially the premium bonds, right? Duration always. The longer the for coupon bonds, duration increases by less than a year for 1 year increase in maturity. In other words, that means the sensitivity of duration with respect to the maturity is less than 1. If maturity, that's exactly what it says. Maturity goes up by 1 year, right? Duration doesn't go up by 1. Now, lower yield bond means discount factor is lower, right? Discount rate is lower. Lower discount rate bonds have longer duration. Yes, you're discounting it with a smaller discount factor. Obviously, working through the weighted average, right? Working through the formula, then it would result in longer duration. Since more distant payments, coupon payments, have relatively higher present values, right? I mean, discount rate is lower, then the future cash flows are discounted less, so ending up in greater present value, right? Relatively higher present value, right? Than when discount rate is higher, right? Thereby accounting for greater share of bond price, right? So distant future coupon payments discounted less, so they have more impact, right? They on the present value of the bond. So again, payments receive greater weights for weighted average, which is, in other words, what's going on? I don't know what's happening, but you all know. Oh, what's happening here? That is basically, that's basically D, right? I mean, and that is rule 3 and rule 4. And rule 3 is pretty much the same thing as Mulkill's theorem number 3. And then rule number 4, other factors, holding other factors constant, duration and interest rate sensitivity of bond price is higher when yield is lower. This is, roughly the same thing as, non-Mulkill theorem number 6. Lebowitz and I mean, what was their name? Lebowitz. Homer and Lebowitz. Homer and Lebowitz, right? which is non-molecule number 6. So think about it. Higher yield reduces more distant payments by greater proportion, right? More, higher discount rate. So this is like, the flip side of rule number 3. If the discount rate is, higher, I mean, the future, distant future coupons will be discounted more deeply, right? So then the higher fraction of the bond price lies in earlier payments, right? Because obviously, in relative to distant future coupons, right? Thereby reducing effective T. What is effective T? Effective maturity. I mean, that's another name. Effective T. That's another name for duration, right? That means, duration. So. Oh yeah. Reducing effective T, right? So at lower, on the other end, at lower yield, lower fraction of price lies in earlier payments. Because, think about it. Now, discount rate is smaller. So the distant future gets discounted less. So it weighs in more in the price of the bond. Therefore, thereby, at lower increasing effective, which is duration, right? Another name for duration, right? Okay, more fractionalizing. Okay. And the rule number 5, duration of a perpetuity, right? Perpetuity is an annuity going forever. It's simply, 1 plus y over y. Okay. Now, I don't have time to, I've always wanted to, prove this, but, it's simply this weighted average, and, it would be an infinite series, right? And we don't have time for that. So, example, yield to maturity 15%, payment $100 annually, and perpetuity, right? And duration is 7.67 years, right? Now this formula, I put it here, but this is called, closed-end formula. And if you think about it, this is a formula to find, duration. And that looks kind of complicated, but of course, just simply from a morphological point of view, right? It's different from the formula we already know of, but then the striking difference, right? Other than very salient, difference is what? Very, contrasting difference. In terms of variable, right? One variable is missing here, and one variable is lacking here. Why? What is that one variable? Comparing it with the duration formula before, right? The significant difference is that there is no bond price, there is no cash flow. Isn't it right? There's no bond price, no cash flow. In other words, that's why it is called closed-end formula. And this is useful when there is no cash flow data, no price data. A price is here, of course, and then cash flow. The only difference is the cash flow. The only thing missing is cash flow. Then all you need to do, in other words, only with the price data and only with maturity and yield, you can calculate duration. Okay, so we're not going to use it right now. But there will come a time when we are going to use that formula. But here, this graph kind of summarizes and shows graphically the differences between rule number 1, 2, 3, and 4. 3 cannot be shown here, but 3 will be shown here. Rule number 3. First of all, rule number 1, zero coupon bond, same maturity, right? Duration and maturity the same, 30 years, right? The vertical axis is duration, right? Horizontal axis is maturity, 30 year, right? Zero coupon bond. But when we have let's take a look at this one. This is the this curve shows the duration of a perpetuity, right? 15% coupon, 15% coupon, and that's very high coupon payment and yield of 15%. So how do I know this is a perpetuity? Well, this is an example of, look at 7.67, or wasn't this the example we just saw, right? Regardless of the payment, right? Yield to maturity 15%, right? 1 plus y over y. So regardless of the coupon payment, in this case, coupon payment is not $100, but it will be 150. But the duration will be 7.67, like this, and then. And this doesn't necessarily have to be the perpetuity because the slope is still upward. If it is perfectly a perpetuity, the slope would be completely flat, right? But anyway, I just wanted to use that as for rule number 5. That is that could be an example of rule number 5 and rule number 2. What was rule number 5? Perpetuity. And what was rule number 2? Holding maturity and yield constant, right? Duration is higher when coupon is lower. So, yes, compare this one and this one. This bond has 3% coupon, same yield but lower coupon, and it has higher duration. The duration is almost like 10 years, right? Whereas, this one, same yield, but, 15% coupon and has much lower duration. And this would be an example of rule number 4. And rule number 4 is what? Other factors constant, other things being equal, right? Ceteris paribus, right? Ceteris paribus. It's going to take time, so I'm not going to write it there. Duration is higher when yield is lower, right? So, other things being equal, duration is higher, almost like 13 years, when yield is lower compared to a 15% yield. Yield is, not even half that, and then, right, duration is much higher, almost, close to 2 times, right? So that is the graphical representation of the determinant, determinants of the duration rule, right? And then this is an example of rule number 3, because, oops, I could have almost closed it accidentally. Rule number 3 has to be shown this way because, it has to do with, different maturities. What was rule number 3? Rule number 3 is the law holding coupons constant, duration generally increases with maturity. Yes. Look, coupon rates, under the same coupon rate, the higher the maturity, right? Of course, the duration, this is duration. These numbers are durations. Durations are increasing with, 6% durations increase, right? Increase. In case of perpetuity, it's always the same, right? Regardless of the coupon rates, right? So that is, that is the look at determinants of the duration. Okay. Next topic will be passive bond management, which we'll talk about, immunization and rebalancing. And so time is up, and I will have to stop recording, and I'll see you guys in the next video.